Guys, we are here to talk to you about the centroid of a triangle. And the centroid is actually the point of concurrency where all the medians of a triangle meet inside the triangle. And you might think that concurrency is a big fancy $10 word, but all it means is a place where more than three lines are crossing at the same time, and that particular point is right there. So we're going to call that the centroid. So it's where all the medians of a triangle cross, and they're all actually crossing inside of the triangle. Now, the next important thing that you need to know about the centroid is that the centroid is located 2/3 of the distance from a vertex to the midpoint of the opposite side. And so I'm going to kind of let you look at each part of this so that you can get a feel for how it works. But what that is saying is that the distance from a vertex to the centroid, that is going to be two parts. No matter what the number is, it's going to be two parts. And then the distance from the centroid to the midpoint of the opposite side, that is 1 point. Okay, so take a look at what that means. That means it's two parts from the vertex, which is right here, to the centroid, and then it's another part to get there. And we'll look at it with numbers in just a minute. So I'm going to go ahead and erase that for just a minute so you can see it going in a different direction. Okay, if I come up here to this vertex, okay, from here to this part is going to be two parts. No matter how much it is, it's going to be two parts of the way. And then when I go from the centroid, which is right here, to the midpoint, that's going to be one part of the way. Okay, so I hope you get comfortable with this, but we'll look at some numbers in just a minute to so that you can see what we're talking about. Oop, I went too far, but let me go back here. Okay, this is kind of one thing that you might look, and I put the word M. That's where that M is yellow, and M is the point where my centroid is, and I'm going to erase that here, having shown that to you. And you are asked to do a couple of things. I've given you various pieces, either the big piece of a median or the small piece of the median. Okay, the small piece of a median is always going to be 1/2 of what the big piece of the median is, and together they add up to be the whole median. But if we'll look at this first problem here, and it asks us to find it's going to ask us to find ME. Okay, well, let's look and see where ME is at. ME is this part right here. Okay, now what you need to ask yourself is, did they give me the big part of the median or the small part? Okay, and remember what I just said. The big part of the median is 2 times as big as whatever the small part is. The small part of the median is 1/2 of whatever the big part of the median is. Well, in this case, you've been given the small part. You see where that 6 is? And you have to find what the big part is. So what we're going to do is we're going to go in here, and it's really simple. I just take that 6 and I multiply it by 2, and I get 12. So the distance from M to E on this triangle is 12. Okay? Now, let's take a look, and we're going to erase a little bit of this so we can see what we need to see. But let's go back and let's look at the distance from M to F. Okay? Well, M to F, let's highlight. Where is M to F at? M to F is right here. And now what we have to ask ourselves, we're on this median, and the median that we're on is from C to F. Okay? That little part right there. Now, is the distance from M to F the big part of the median or the small part of the median? Well, that's right. It is the small part of the median. And so to find out how much it is from M to F, we are going to say 16 divided by 2, and we're going to get 8. So the distance from M to F is 8. That's where that 8 goes. Okay? So if you need to, go ahead and write that down. And we'll get ready to do this last part, which is the distance from M to D. So I'm going to erase that as you get prepared. Now, what's the distance from M to D? Well, first of all, the segment AD is my median, and I have to look, okay? Well, you know where the M is, and the M kind of got torn up there. So is the distance from M to D the big part or the small part of the median AD? And you are correct if you're saying that the distance from M to D is the small part. So I take that 10, I divide it by 2, and I get 5. Okay? A couple of things that you want to remember about this particular problem is that this dealt with they didn't give us the whole thing, they just gave us numbers inside, so parts of the median, and that's why we were able to use these rules. And the rule basically has something to do with 2/3 and 1/3, and that's why you multiply the short pieces by 2 to get the big piece, and you divide the big pieces by 2 to get the little piece.